Good afternoon to all. Am I audible? Can anyone mention? Am I audible? Can anyone mention? Am I audible? Okay then. I'll start the class. So numerical problems on signal flow graph. So I will start with this problem. So okay, so we have to find the overall transfer function for the system whose signal flow graph is shown in this figure. So this is our signal flow graph. In this signal flow graph, if we carefully observe, total there are 8 nodes. Okay, node 1, node 2, node 3, node 4, node 5, node 6, node 7 and node 8. So the gain value, the transmittance value, while signal is traveling from node 1 to node 2, the gain acquired by this branch, okay, while traveling from node 1 to node 2 is 1. The transmittance acquired or the gain acquired by the branch while traveling from node 2 to node 3 is G1. The gain acquired by the this branch while traveling from node 3 to node 4 is G2 and so on. Okay, so the gain acquired by this branch which is traveling from node 4 to node 5 is G3 and so on, and the gain acquired by this branch which is traveling from node 7 to node 6 is minus H3, and the gain acquired by this branch which is traveling from node 4 to node 3 is minus H1. The gain acquired by this or transmittance acquired by this branch which is traveling from node 5 to node 2 is G6, and the gain acquired or the transmittance acquired by this branch which is traveling from node 5 to node 3 is minus H2. Okay, so here in this problem, first of all we must determine the first step is to determine the forward path gains. So if you carefully observe here the arrow marks, just see the signal direction. The signal from node 1 to node signal is traveling from node 1 to node 2, node 2 to node 3, node 3 to node 4, 4 to 5, 5 to 6, 6 to 7, 7 to 8. So this is one forward path. And let us check one more. Another forward path is from node 1 to node 2, from node 2 to node 5, node 5 to node 6, node 6 to node 7, node 7 to node 8. So this is another forward path. So the forward paths, till now we have got 2 forward paths for this signal flow diagram. So let us check after coming to node 3. So there is a return path here, there is a return path here. So there is no other forward path. So only 2 forward paths are there for this given signal flow graph. Therefore, if k is the notation for number of forward paths, then k value is equal to 2. If k is the notation for number of forward paths, then k value is equal to 2. So the number of forward paths in the signal flow graph are 2. Therefore, let us give some notations for these forward paths. The notations are the So the forward path gains notations are P1 and P2. So I just wanted to modify this. Okay, so this is it, forward path gain. Let us assume notations P1 is the first forward path gain. P1 is the first forward path gain. P1 is the first forward path gain. P2 is the second forward path gain. So this is our first forward path traveling from, the signal is traveling from node 1 to node 8 directly. Okay, and second forward path signal is traveling from node 1 to node 2, from node 2 to node 5, and from node 5 to node 8. So this is our second forward path. So the first forward path gain notation, okay, gain of first forward path notation is P1. Gain of second forward path notation is P2. We have assumed those notations. So the gain of first forward path is here, one is there, so forget about it, G1 into G2 into G3 into G4 into G5. Okay, and gain of the second forward path is G4 into G5 into G6. Yeah, there is G6, G4 and G5 are there. So the transmittance value, whatever is given in the question, that we have to take. Okay, gain values, whatever is mentioned in the question, that we have to take. So in the question itself, they have given transmittance gain acquired by this branch from while traveling from node 1 to node 2 is 1. Gain acquired by this branch while traveling from node 7 to node 8 is 1. So for other branches, they have given G1, G2, G3 and G4. So whatever is given in the question, we have to consider those gains as it is. Okay, we can't modify them. So G6, G4 and G5 are the transmittance values of these branches 2 to 5, 5 to 6 and 6 to 7, and the transmittance value of the branch 7 to 8 and 1 to 2 are 1. So these are the gain, forward path gain values. P1 is the forward path gain, the P2 is the forward path gain. Now let us see the individual loop gains. So in order to determine individual loop gains, we must know the individual loops in the given system. So let me copy. Step number 2 is individual loop gains. So let me copy that diagram here. Or I will just okay, so instead of copying it there, so I have copied in some other slide, so that again and again I can get back to this slide. So here individual loop gains, if I want, I must know the individual loops in the given system. So how many individual loops are there? I must know that in order to determine the individual loop gain. So if you carefully observe here, okay, if you carefully observe here, from 1 to 2 there is no loop, from 2 to 3, okay, 2 to 3, and you can see from there is another branch connected to 2. So let us check whether it's a loop or not. 2 to 3, from 3 to 4 there is, it's not moving forward, it's the return path. So from 2 to 3, 3 to 4, 4 to 5, from 5 you just observe, is it returning back? No, it's not returning back, so this is not a loop. Okay, so there should be a return path for the loop to exist, so it's not the loop. Now let us move back to move forward to this node 3. From node 3 to node 4, forward path. From 4 to 3 again return path is there, so this is a loop. 3 to 4 is a loop, this is loop number 1, let us assume. Okay, now from there is another branch here which is connected to this node 3. Therefore let us move from 3 to 4, 4 to 5. If you observe here, yes, this from 5, there is a return path from node 5 to node 3. So this is another loop 2. Okay, and let us move forward from 5 to 6. It seems there may be a loop here. Let us check. From 6 to 7, the signal is moving forward. From 7 to 6, it is returning back. So this is our loop 3. So in this given system, there are, I'm sorry, it is 3. I have written 2. In this given signal flow diagram, total there are 3 loops. Okay. So there are 3 loops. So you can write down individual loop in step number 2. Number 2 is individual loop gains. So mention there are 3 loops in the given system. Okay, there are 3 loops in the given system. So, and loop gain notations, you can assume the loop gain notations your wish. You can assume, but they should be assumed in certain pattern or sequence. Your wish, you can assume whatever loop gain notations that you want. Here, okay, I have assumed the loop gain notations as P11 and P21. So the loop gain notations I have assumed here are P11 and P21. So first of all, I'm sorry, total 3 loops, isn't it? So P11, P21 and P31, total 3 loops. So loop 1, draw the loop 1 and write down P11 value. What is it? Just simply multiply the gain values. Minus G2 into H1. Draw loop 2, okay, and write down the gain values. P21 is equal to minus G2, G3, H2. Draw loop 3 and P31 is equal to minus G5, H3. Okay, so this is it. We have got 3 loops. We have assumed some notations for loop gains and we have written the loop gain values from the signal flow graph. So from each loop you can write down the signal flow values. Now let us go to this third step. Third step is to get the gain products of 2 non-touching loops. Okay, so let us check whether there are any non-touching loops first of all. Okay, so let us check. This is our figure. Okay, now how many loops did we get? What were our loops? I will just mention the loops. Our loops were 3 to 4. Where is my pen? This was one loop, loop 1, loop 2 and loop 3. So if loops are said to be non-touching, there should not be a common node between the loops. Okay, if loops are non-touching, there should not be a common loop between the nodes. Okay, so if you see here, loop 1 and loop 2 are touching, isn't it? They have a common node. What is the common node? Common node is 3. You can mention in the chat box if you are able to follow the class. Okay, if you are able to follow the class, if you really want to learn the concept and you are joining this class to learn the concept. Okay, so just for namesake, I hope you have not joined. Those who want to learn the concept, those people might have joined, not for show off, isn't it? Okay, some people just show off. Show off is not required. Okay, so if we really want to do something, we should do something, not for show off. Okay, so here loop 1 and loop 2, they have a common node, so they are not non-touching loops. If you compare this loop 3, loop 1 with respect to loop 3. They don't have common nodes. So this is one pair of non-touching loops. Okay, they are one pair of non-touching loops. And one more pair is loop 2 and loop 3 also don't have any common node. So loop 2 and loop 3, they are also non-touching pair. Okay, so how many pairs of non-touching loops did we get? Two pairs. Okay, so there are two non-touching loops, we can say, or there are two combinations, we can say. There are two combinations of non-touching loops. Okay, there are two combinations of non-touching loops. There are two combinations of non-touching loops. So let us, anyhow, we have to determine the gain product of the non-touching loops. Let us give the notation. Since there are two pairs, the first pair gain product of two non-touching loops, let us assume it is P12. Second pair gain product of non-touching loop, let us assume it is P22. Okay, it is P12 and P22. Okay, so what is loop 3 4? Loop 1, I think so. This was loop 3 4 was loop 1, and 6 7 was loop 3, isn't it? It was loop 3. So these two are non-touching loops. Okay, one pair of non-touching loops. So let us determine the gain product. Okay, so what is the gain of this 3 4? It is G2 into minus H1, isn't it? Okay, so G2 into minus H1, that is G2 H1. Similarly, what is the gain product of this loop? It was G5 into minus H3. So minus, I used my cursor very slowly, but it happened. Okay, it's okay. G5 into H3. Okay, G5 into H3 minus G5 into H3. So minus G2 into H1 and minus G5 into H3. Okay, so now we want what do we want? Gain product. Okay, gain product of two non-touching loop. Simply multiply this gain, this loop gain with this loop gain. You will get the P12 value. Okay, P12 is equal to what? Product of minus G2H1 and minus G5H3. Okay, so what do you get? This is it. P12 is, okay, P11 into P31, we can say product of minus G2H1 and minus G5H3. What do you get? Minus minus cancel. G2, G5, H1, H3. Okay, G2, G5, G5, H1, H3. Okay, similarly, what is P22? P2, it is the gain product of loop 2 and loop 3. So what is loop 2 gain? It is G2, G3 minus H2, means minus G2, G3, H2. This is the gain product of not gain product. This is the gain of loop. This loop. What is the gain of this loop? Minus G5H3, isn't it? G5 into minus H3. So G5H3. This is the loop gain value. Okay. So this is the loop gain value of this loop. This is the loop gain value of this loop. Simply multiply these two. Okay, multiply these two gain values. So minus G2 H2, minus G2 G3 H2 into minus G5 H3. What do you get? Just minus minus cancel. G2 G3 G5 H2 H3. Okay, G2 G3 G5 H2 H3. This is the gain product of two non-touching loops. Okay. So step number 3, if people can write it down, whoever wants to learn the concept and who have joined to learn the concept. Okay. So you just write it down. As soon as you complete, you just mention. So I hope you have completed this this slide you have written in your notes. So write down this. Okay, then now calculation of delta, okay, and delta k. So formula for calculating the delta is 1 minus, okay, 1 minus, what is P11, P21, P31, do you remember? I hope you won't remember. You will not remember, I know that. So they are the individual loop gains. So 1 minus what is it? Sum of individual loop gains plus, okay, plus sum of the non-touching loop gains, okay, plus what? Sum of the non-touching loop gains. So 1 minus what? 1 minus, one second. Okay, so what is delta? Delta, you must actually, it is here, it is dark. Let's just see if I am able to fill it with, yeah, this is it. Delta, you must, it should be like this. Okay, so what is delta and delta k? We have to determine delta 1 and delta k. So what is delta? Delta is, formula is 1 minus sum of the individual loop gains, okay, plus sum of the gain products of non-touching loop gains. So you just add it, okay, add it and you just simplify it. You will get 1 plus G2H1 plus G2G3H2 plus G5H3 plus G2G5H1H3 plus G2G3H5H2H3. This simple, it's nothing is there, plus or minus some. Okay, that's what we are getting. Okay. Now we have determined the delta. Okay, we have determined the delta. Now let us determine what is K. What is K? What is K? K is what? Number of forward paths. You can mention in the chat box. If you are really listening to the class, if anyone is listening to the class, then they can mention in the chat box what is K value. Okay. You can mention in the chat box what is meant by K. K is number of forward paths. So what is delta K? Delta K, K is 2. So delta K is what? Delta 1 and delta 2. Delta K is delta 1 and delta 2. So we have two delta K values. One is delta 1, other one is delta 2. Okay. So what is meant by K? They are the number of forward paths. So there are two forward paths. That's what we have seen. So is there any part which is not touching forward path 1? Any part of the graph, signal flow graph, which is not touching forward path 1, is there any part? There is no part. Okay, so there is no part which is not touching, there is no part of the graph which is not touching the forward path 1. Therefore, 1 minus 0. Okay, since there is no part which is not touching forward path 1, okay, therefore 1 minus 0. Okay, so what is delta 1 now? Delta 1 is equal to 1 minus 0, it is 1. Okay, 1 minus 0, it is 1. Similarly, we have to determine delta 2. Okay, so is there any part of the graph which is not touching forward path 2? So let us see the forward path once. This is the graph. Let us see the forward path 2. What was our forward path 2? Where is my pen? Where was the forward path 2? This was our forward path 2. Isn't it? This was our forward path 2. In this forward path 2, if you just carefully observe, node 2 and node 4. Okay, they are not at all touching. Node 2 and node 4, they are not at all touching forward path 2. So this loop, okay, it is not at all touching forward path 2. Loop 3, 4. Okay, this loop is not at all touching forward path 2. Okay, that is P11, loop P11. Loop gain value is P11. For this loop, gain is P11. That is, what is the gain value? G2 into minus H1, that is minus G2H1. Okay, so loop gain. So 3, 4 is not at all touching forward path 2. Okay, so since it is not at all touching, where was my, this is it. So it was not at all touching forward path 2. Therefore, okay, consider the part which is not touching forward path 2. Okay, so formula is 1 minus, okay, the part of the gain value of the part which is not touching the forward path 2, that is P11. That is 1 minus of minus G2H1, that is 1 plus G2H1. Okay, so 1 plus G2H1. So this is our delta 2. So we have got an expression for delta, we have got an expression for delta 1, we have got an expression for delta 2. Okay. So you just take it, I will just give a minute to copy it down. Just note it down in your notes. Yeah, I hope you have completed. Now let us determine the step number 5 is to determine the transfer function. So let us determine the transfer function. Let us assume notation for transfer function is t. Okay, according to Mason's gain formula, the transfer function t is given by 1 by delta sigma k pk delta k. So 1 by delta, what is k value is 2. So p1 into delta 1 plus p1 into delta 2. Okay, P1 into delta 1 plus P1 into delta, P2 into delta 2. Okay. So what is T now? See here I have written something, so I might not have written. Okay, it's okay. So what is T is equal to? So here something is missing, some formula. Okay. So here T is equal to what? Here I might have written T. I'll just write it down. So this is it. This is it. So T is equal to what? 1 by delta into P1 into delta 1 plus P2 into delta 2. So what is 1 by delta? Just now we have seen in the previous slide, this is our 1 delta value. So 1 divided by delta, this is the denominator is the whole delta. What is P1? What is P1? What is P1? P1 is what? Forward path gain of path 1. Path 1 gain is how much? Path 1 gain is G1, G2, G3, G4, G5 into delta 1. How much is delta 1? Delta 1 is 1. Okay, delta 1 you just see here. Delta 1 is how much? Delta 1 value is 1. Okay, next plus, okay, plus what is P2? It is the forward path gain of path 2. What is it? G4, G5, G6 into delta 2. What is delta 2? Delta 2, this is delta 2. How much is it? 1 plus G2 H1. 1 plus G2 H1. Okay, that is delta 2. So T is equal to 1 by delta. Okay, 1 by delta into P1 into delta 1 plus P2 into delta 2. If anyone wants me to repeat this concept, I will repeat or I will go to the next numerical problem. If anyone is watching and okay, it's wastage of time as it seems. Okay, I'll go to the next slide. So if you have not written, you just mention in the chat box so that I will repeat. Okay. So if anyone is really listening. So next problem. To find the overall gain of the system whose signal flow graph is as shown. So this is the signal flow graph. This is the signal flow graph. Okay. So in the signal flow graph, so R of S is the input and C of S is the output. And if you observe carefully, they didn't give us the node values, isn't it? Node notations. Notations for the nodes are not given here. So we have to write it. Okay. We have to write the node notations since it is not given in the question. So it is in our hands to write the notations. So this is it. This is the signal flow graph. So I will just give a minute to copy it down. Okay, so let us give the notations. See here, I have assumed this one as 1, 2, 3, 4, 5, okay, 6, 7 and 8. Total 8 nodes that I have got here. So you can write down the nodes in the same diagram. No need to draw again. Okay, so this is it. These are the nodes. Total 8 nodes that I have got. First step is to determine the forward path gain. So let us check how many forward paths are there in this diagram. So I will just see 1 to 2. Okay. So 2 to 3, 3 to 4, 4 to 5, 5 to 6. This is one forward path. Okay. So I have got one forward path. Next, let me see from 1 to 2, 2 to 7. Okay, 2 to 7, 7 to 8. If you are able to, if anyone is listening to this class, and if you are able to find out how many forward paths are there, you must mention, you just mention in the chat box. Okay, 8 to 5, 5 to 6. This is second forward path. Okay, next, 1 to 2, 3 to 2 to 3, 3 to 8, 8 to 5, 5 to 6. This is another forward path. And next, 1 to 2, 2 to 7, 7 to 4, 4 to 5, 5 to 6. This is another forward path. Next, 1 to 2, 2 to 7, 7 to 4, 4 to 3, 3 to 8, 8 to 5, 5 to 6. This is another forward path. Next, 1 to 2, 2 to 3, 3 to 8, 8 to 7, 7 to 4, 4 to 5, 5 to 6. This is another forward path. Okay. So I think I have covered all forward paths. Total I have got total 6 forward paths. You will get 6 forward paths. So what is K value? K value is 6. So no one is mentioning in the chat box. Very good. Keep it up. So 6 forward paths are there. That means K value is 6. So forward path gains, let us give some notations for the 6 forward paths. Gain values P1, P2, P3, P4, P5 and P6. Okay, P1, P2, P3, P4, P5 and P6. So what is the gain of forward path? What is our first forward path? This was our first forward path. Okay, which I have already discussed. So what is the gain of that forward path? What is the gain? You just observe here, gain value they have given 1, G2, G4, G6 and 1. Okay, so what is the forward path? P1 equal to G2, G4, G6. P1 is equal to G2, G4, G6. Okay, so let us go to the next second forward path. So second forward path 2, this is our forward path 2. What is the P2, P2 gain? P2 is equal to what? P2, okay, gain value. P2 is equal to what? P2 is equal to G3, G5, G7. Okay. P2 is equal to G3 into G5 into G7. This is P2 value. Okay. Now let us see third forward path. What is the gain value? P3. Okay. P3 is equal to how much? P3 equal to, there is G1, G2 and G7. Once, no need to write 1. So G1 into G2 into what? G7. Okay, G1 into G2 into G7. G1 into G2 into G7. Okay, so next fourth forward path, P4. Okay, P4, fourth forward path P4. Gain values are G3, G6 and G8. Simply multiply the gain values, that's it, or transmittance values. So G3, P4 equal to G3, G6 and G8. G3, G6 and G8 is P4. So I'll just give a minute. If you are really listening to the class, if anyone, you can copy it down. Okay, next fifth forward path gain P5. P5 is equal to, so P5 is equal to how much? G1 into G3 into G7 into H1. H1 is minus H1. So minus G1 into G3 into G7 into H1. Okay, I'll just erase it. If anyone is copying it down, for them it won't be nice. Okay, so what about the forward path gain of path 6? Simply multiply the products. Okay, so P6 is equal to P6 is equal to how much? G1, G2, G1, okay, G1 into G2 into G6 into G8 into what else? G1, G2, G6, G8. This is 1 and this is 1, and what is left over? Minus H2. So into H2 minus, instead of writing it here, you can write it here, minus H2. Okay, minus H2. So this is it. If you have drawn the diagram, I will show you the forward path gain values I have written in the next slide. This is it, 6 paths. So these are the gain values, forward path gain values. I will just, yeah, this is it. So these are the forward path gains. P1 equal to G2, G4, G6. P2 equal to G3, G5, G7. P2 equal to G3, G5, G7. P3 is G1, G2, G7. P4 is G3, G8, G6. It's better to write in sequence. I didn't writ P P4 in sequence, and P5 equal to minus G1, G3, G7, G8, H1, and P6 is minus G1, G2, G6, G8, H2. Hope you have written. So let us determine the individual loops. Okay, how many individual loops are there? Let us see. So I am showing you this slide, but I will go back to the actual diagram. Given question. Where is it? Yeah, yeah, it's with notations. I want with notes. So this is it. So let us determine how many loops are there in this. So now to determine the loop gains, I need loops, isn't it? So I have to determine how many loops are there. So if I see here, if you observe here, 3 to 4, 4 to 3 is a loop. 7 to 8, 8 to 7 is a loop. Okay, I have got two loops. Okay, two loops I have got. And let me see. What else do I have? From 2 to 3, 3 to 4, 4 to 5, 5 to 8 is not there. So it is not a loop. Okay, so another loop what I can find here is from 4 to 3, from 3 to 8, from 8 to, okay, I'll once again draw it. So from 4 to 3, from 3 to 8, 8 to 7, 7 to 4. Okay, this is one loop. Okay, so I think I don't think I have any other loop here. So total three individual loops are there. Total three individual loops are there. So total three loops are there. Loop 1, loop 2 and loop 3. So three individual loops are there. What we have to do in this step 3, individual loop gains we have to determine. So individual loop gain value sum formula P11 notations, not formula, sorry. Notations P11, P21 and P31. These three are the notations of individual loop gains. Okay, this two have merged here. Okay. So this is it, loop 1, this is our loop 1, loop 2, loop 3. Loop gain values, notations we have assumed P11, P21, P31. So what is P11? G4 into minus H1. So that is minus G4 H1. Okay, P11 is what? G4 into minus H1. That is minus G4 H1. Okay, next, what is the loop 2 gain value? G5 into minus H2. That is P21 equal to minus G5 H2. And what is loop 3? That is loop 3 gain value, it is P31 equal to G1, G8, H1, H2. So minus H1, minus H2, minus minus cancel. So you'll get G1, G8, H1, H2. This is loop 3 gain value. So just write it down. Okay, now next, gain product of two non-touching loops. Okay, gain product of two non-touching loops. So let us see how many non-touching loops are there. How many pairs of non-touching loops are there here. So you can see, of course, what were our loops? Total, how many loops were there? Total 3 loops were there. So total 3 loops, it's where you can even identify the non-touching loops from here itself. You just see here loop 1 and loop 2, you just see, is there any common node between loop 1 and loop 2? No. So this is one pair of non-touching loops. Okay, that's it. Next, you just compare loop 1 with loop 3, loop 1 with loop 3. What is it? They have common nodes. 3, 4 are common here. 3 and 4, they are common. So they are not non-touching. They are touching loops. And if you compare loop 2 and loop 3, they have common nodes 7 and 8. Okay. So they are also touching. So the only one combination of non-touching loops here is 3, 4 loop and 7, 8 loop. Okay. So 3, 4. This is it. This loop and this loop, they are non-touching loops. So there is only one combination of non-touching loops. I think I have written here one combination of two non-touching loops I have written here. Okay, so let us assume the gain product of these two non-touching loops, some notation P12. P12, it is the gain product of one non-touching loops. Okay, so P12 is what? Gain of this loop. What is the gain of this loop? G4 into minus H1, and the gain of the other loop is G5 into minus H2. So just take the product of those two, you will get G4, G5, H1, H2. G4, G5, H1, H2. Now let us calculate this delta and delta k values. So what is our k? So how many forward paths were there? Total 6 forward paths were there. So k is 6. So let us calculate the delta and delta k. So I will just, here they have become dark. I will just remove this darkness. This delta. Okay, so let us see. So what is delta? 1 minus what? 1 minus what? It is the sum of the individual loop gains. How many loops were there? Total 3 loops were there, isn't it? There were 3 loops, individual loop gain values. Okay. So individual loop gains were, what were they? P11. Individual loops gains were P11, P21 and P31. So simply 1 minus summation of individual loop gains plus sum of the non-touching loop gains. How many non-touching combinations of loop gains did we get? Only one. So plus P12. Okay. So 1 minus sum of the individual loop gains plus sum of the non-touching loop gain values. Sum of the non-touching loop gain values, two non-touching loop gain values, only one combination we got. So P12. Just substitute all those things here. You will get the delta. So delta is equal to what? 1 plus G4 H1 plus G5 H2 minus G1 G8 H1 H2 plus G4 G5 H1 H2. Okay, that is it. Now we have to determine delta K. So what is delta K? Delta K is 6. So delta 1, delta 2, delta 3, delta 4, delta 5 and delta 6. Total 6 delta C you will get. Delta Ks you will get. So first total 6 forward paths are there, isn't it? So is there any part of the graph which is not touching path 1? Okay. So let us check that. In order to determine delta 1, let us check, is there any part of the graph which is not touching path 1? So what was our path 1? Path 1 was, our path 1 was, here it is there in this diagram. It was 1, 2, 3, 4, 5, 6. This was our path 1. Okay. So if we observe here 7 and 8 nodes, okay, they are not touching the forward path 1. Okay. So the loop, you must consider the loop of this 7 and 8. Okay. So loop gain, you just consider the loop gain of 7 and 8 nodes. So you can see here, I have considered this. You can see loop here, 7 and 8 loop. They are not touching this forward path 1. So 1 minus loop gain of this loop, 7 and 8 loop. So loop gain value was minus G5H2, minus of minus plus. So 1 plus G5H2 is our delta 1. Okay, that is our delta 1. Okay, so we have determined the part of the graph which is not touching path 1, and from that we have determined delta 1. Now let us determine the part of the graph which is not touching forward path 2. Okay, let us go to the forward path 2. So you can go to this diagram itself, forward path 2. This is our forward path 2. If you observe in forward path 2, this 3 and 4 nodes not at all touching the forward path 2. Okay, so the loop, this 3, 4 loop, this loop, okay, this loop will not touch the forward path 2. So that loop gain value we will consider. Okay, next slide. So this is it. Okay, this is the loop. This is the loop. Okay, so this is the loop. So what is it? 1 minus this loop gain value. How much is it? G4 into minus H1 means minus G4 H1. So minus G4 H1. So 1 minus of minus G4 H1, you will get 1 plus G4 H1. Okay, you will get 1 plus G4 H1. Okay, so we have got delta 2. Now let us determine delta 3. Delta 3 means let us see if there is any part of the graph which is not touching this forward path 3. So let us go back to the forward paths. Forward path, this is a forward path 3. So you can see here node 7 and node 4, only particular nodes. Okay, there is no loop which is not touching forward path 3. So we must have a loop which is not touching forward path 3. There is no such thing. Similarly, in forward path 4 also there is no loop which is not touching forward path 4. Similarly, for forward path 5, if you observe, there is no loop which is not touching forward path 5. Similarly, there is no loop which is not touching forward path 6. Okay, so since there are no loops, no part means here they may mention in the content, they may mention there is no part. Part means loop, you must consider the loop. Okay, part, even if it is mentioned part, but it is loop. So there is no part of the graph which is not touching the forward path 3, 4, 5, 6. Therefore the delta 3, delta 4, delta 5, delta 6 values are 1. Okay, Therefore, delta 3, delta 4, delta 5, delta 6 values are 1. Okay. Now, let us determine the transfer function. So let us determine the transfer function. So transfer function T. So T is equal to, formula is what? According to Mason's gain formula, formula is T is equal to 1 by delta sigma k pk delta k. So what is this? Is T. So T is equal to, substitute 1 by delta, whatever equation that you have got, you just substitute it. This is the denominator. Substitute P1 value. P1 is G2, G4, G6. Substitute delta 1 value, that is 1 plus G5, H2. Substitute plus P2. What is P2? This is G3, G4, G5, G7 is P2. Substitute delta 2. Delta 2 is 1 plus G4, H1. Substitute P3. P3 into delta 3. Delta 3 is 1, I think so. Delta 3 is 1. So P3 into delta 3 is P3. So P3, substitute P3 value, G1, G2, G7. Delta 4 value is 1. So substitute P4 here. P4 is G3, G6, G8. Delta 5 value is 1. So substitute P5 here. P5 is minus G1, G3, G7, G8. Delta 6 value is 1, therefore substitute P6. P6 is minus G1, G2, G6, G8. So this is it. So this is the overall transfer function for this signal flow graph. This is T. So I'll just give a minute to just copy it down. Okay, one more numerical problem I will solve, and I think I will conclude after that. So find the overall gain C of S by RFS for the signal flow graph shown in the figure. So this is the signal flow graph which has been shown. You can see notations for the nodes they have given, so we need not worry about it. I will take the laser. Okay, node 1, node 2, node 3, node 4 and node 5 is given. All nodes have been mentioned. The gain acquired or the transmittance acquired by this branch while traveling from node 1 to node 2 is G1. Similarly, gain acquired by this branch while traveling from node 2 to node 3 is G2. Again, another signal travels from 3 to 4, whose gain is minus H2. And a gain that is acquired by this branch, which is traveling from node 3 to node 4 is G3. From node 4 to node 2, the gain acquired is minus H2. And there is an individual loop, a single node loop, we can say. There is a single node loop whose gain value is G5. And there is the gain acquired while traveling from node 4 to node 5 by this branch is G4. And again, one more branch travels from this node 3 to node 5, whose gain is G6. And one more branch starts from node 5 to node 2, whose gain is minus H3. Okay. Now let us see how many forward paths are there in this. One forward path is from 1, 2, 3, 4, 5. It is clearly understood, isn't it? It is clearly understood. So let us see one more forward path. Is there any other forward path here? So from 1 to 2, from 2 to 3 is over. 2 to another path, you can't go in that way. In this path also you can't go. In this path you can't go. So they are returning paths, isn't it? So you can't go. From 1 to 3, just 1, 2, 3. From 3 to, yeah, 3 to 5. Okay, so that is it. I think there is no other path here. So total 2, already it is in this slide I have already mentioned. So forward path gain. There are 2 forward paths, so k is equal to 2. K value is 2 since there are 2 forward paths. Okay, now let us determine the forward path gains of forward path 1 and forward path 2. So see here, forward path 1, this is our forward path 1, this is forward path 2. So for gain of forward path 1 is how much? G1, G2, G3, G4. That's it. P1 equal to. Notations of forward path gains P1 and P2. Two forward paths. Notations for those forward gain values are P1 and P2. So what is P2 gain for gain of the forward path 2? G1, G2 and G5. G1, G6. Oh, sorry. This is G6. Okay. I thought it is G5. It's not clearly visible. Huh? This image, if I just expand it, it's not visible. Suddenly I thought it is G5. Okay, this is G6. Okay, G1, G2 and G6. Okay. Now let us see the individual loop gains. So individual loop gains, you just check the number of loops. How many loops are there in the given system? From that, you can write down the individual loop gain values. So let us go back to the question. This is our question. So in this, let us check how many individual loops are there. So first loop, it's better to start with node 2, isn't it? It's better to start with node 2. From node, from node 2 to node 3, 3 to 2. This is one loop. Okay, this is one loop. Okay, we have got one loop. Next, from node 2 to node 3, node 3 to node 4. And from 4 it is returning back, isn't it? From 4 it is returning back. This is another loop. And next, from node 2 to node 3 to 4, 4 to 5. From 5 to 2. Yeah, this is another loop. Okay. And one more single loop, as I already told, one node loop. This G5. This is another loop. And let me see. 2 to 3. 2 to 4 I have already taken. 2 to 3 to 5. And from 5 to 2. Okay. This is another loop. Total how many did we get? Total 5 loops we have got. total 5 loops. There are total 5 loops. So there are total 5 individual loops. So here I might have written, did I write? Yeah, I have written 5 individual loops. Let us give the notations for the loop gain values. Notations are P11, P21, P31, P41 and P51. Okay, notations for the loop gains. Okay, so let us assume this as loop 1. If this is our loop 1, or whichever loop you want to consider as loop 1, you can consider it, so it doesn't matter. So P11 is minus G2, G3, H1, and loop 2 gain is P21 is minus H2, G2. P31 loop gain value is minus G2, G6, H3. Minus G2, G6, H3. Okay. So these are the loops, 3 loops and their loop gain values. Loop 1, loop 2 and loop 3. Similarly, loop 4. Similarly, loop 4, I will just make some modifications here. Okay, leave it. I wanted to do something else. Okay, I will do it later. So loop 4, these are loop 4. So loop gain value P41, P41, where is my cursor? P41 equal to minus G2, G3, G4, H3, G2, G3, G4, H3, minus H3 is there, that's why. Similarly, what is P51? Only it's a single node loop, so it is P51 is G5. P51 is G5. Okay, next let us determine the gain products of non-touching loops. So let us see how many combinations of non-touching loops are there. That you can find out from the loops itself. So let us see the loops to determine the non-touching loops. So how many loops are there? Total 5 loops are there. So compare loop 1 with loop 2. Is there any common node? 2 is there. 2 is there. So there it's not non-touching loop. These two are not non-touching loops. Loop 3 and loop 2, they also have common nodes. So they are also not non-touching loops. Okay. They are also not non-touching loops. And let us compare, node 2 is there in loop 4, so it is also not non-touching loop. If you compare with node 5, loop 5, 4 is there, here also 4 is there, so loop 1 is not non-touching to the other loops. What about the other loops with respect to the other? Now let us start with loop 2. Loop 2, common node, common node, common node. What about 4? Here it doesn't have any. Okay, it doesn't have any common link between these two. So I can say loop 2 and loop 5. They are non-touching loops. Okay, loop 2. There is no 4 here, isn't it? And loop 5. They are one combination of non-touching loops. Okay. So that is one combination of non-touching loop. So let us check for another combination if there is any available. So here let us go for loop 3 now. Loop 3, 2, 3 and 5 nodes are there. 2, 3 and 5 are there. In this 2 is there, so it is touching loop. What about loop 5? 4 node is there, 4 is not there. So loop 3 and loop 5, again they are non-touching loops. Okay. So we have got two combinations of non-touching loops. Now let us compare loop 4 and loop 5. So node 4 is there, node 4 is there here. Okay, so these two are touching loops. So we have got only two combinations of non-touching loops. Okay, we have got only two combinations of non-touching loops. So gain product of two non-touching loops. What did we get? We have got two combinations of non-touching loops. Let us give the notations for the gain values of these two non-touching loops. Notations are P12 and P22. Okay, notations for these gain products of these non-touching loops is P12 and P22. Okay, now let us see the first combination of non-touching loops and let us write down the gain products. So this this loop's gain is G2 minus H2, that is minus G2 H2. This is G5. So P21 is equal to what? P12 is equal to P21 into P51. So what is it? Minus G2 H2 and into G5. So you will get minus G2 G5 H2. Okay, so another pair of non-touching loop gain. So these two are non-touching. So let us determine the gain of this. So what is the gain of this? G2 minus H3, G6. No, is this G6 or G5? It's G6 only, not G5. So again and again, I'm just it is 6 only, but I am confusing. I am thinking that this 5 is looking like 6. That's it. Okay, it's my problem, nothing else. So this is the node. So for this here itself, it is G5 is written, so I need not worry about it. So what is the gain product of this? Minus G2 G6 H3 into G5. So I might have written in the next slide. P22 is equal to P31 P1 P51. So minus G2 G6 H3 into G5. So you just multiply it, you will get minus G2 G5 G6 H3. So whoever is listening to this class, they can write it down. They can write it down. Okay. So next is to calculate the delta and delta k. To calculate the delta and delta k. So what is delta? Delta is equal to 1 minus sum of the individual loop gains. How many total? 5 loops were there. So just add them plus some of the pairs of some of the combinations of non-touching loops. There were two pairs of non-touching loop combinations. So you just add them. So you will get this. Okay, if you add it, you will get this. So delta is equal to 1. I didn't expand it. I have simply written it and I just left it. Okay, I didn't expand it. I might have expanded it. So delta, what you are going to get here is 1 plus G2 G3 H1. Okay, plus H2 G2 plus G2 G3 G4 H3. It is not there on that slide, but I'm giving the next equation. I'm telling you the next equation. So that is 1 plus G2 G3 H1 plus G2 G2 H2 plus G2 G3 G4 H3 minus G5 plus G2 G6 H3 minus G2 H2 G5 minus G2 G5 G6 H3. Okay, so you must have patience and you must have interest to learn the subject. Then only you can write the next equation, you people, whoever is watching this. Okay, whoever is watching this video, you people can write down. You can write down the next equation. Now, what is k value? How many forward paths were there? How many forward paths were there? I think there were only 2 forward paths. So k is 2. So you can determine delta 1 and delta 2. Okay, delta 1 and delta 2. So to determine delta 1, let us check, is there any part of the graph which is not touching path 1? All nodes are here, isn't it? If any path consists of all nodes, that means all parts are touching that path 1. Okay, all nodes are there means all parts are touching. So there is no part of the graph which is not touching path 1. There is no part of the graph which is not touching path 1. All are touching it. Okay, therefore delta 1 is equal to 1 minus 0. Okay, no part is non-touching. Okay, all parts are touching. So delta 1 is equal to 1. Delta 1 is equal to 1. Now let us determine delta 2. So is there any part of the graph which is not touching path 2? Path 2. Okay, so let us check that. So this is it. You can see node 4. At node 4 there is a loop, isn't it? There is a loop. This loop is not touching path 2. So there is one part which is not touching path 2. What is the loop gain of that part? This is the loop. Okay, this is the loop. This is the loop which was not touching path 2. Okay, so what is the gain of that path? G5. G5 was the gain of that path. Therefore 1 minus G5, sum of all the non-touching path loops, isn't it, for that particular path. Okay, for that particular forward path. Okay, so here we have only 2 forward paths. So we have got only delta 1 and delta 2 values. So delta 2 is equal to what? 1 minus G5. Delta 2 is 1 minus G5. So why G5? It is the gain value of that particular loop which is not touching path 2. Okay, so we have got delta 1, delta 2 and we have got delta. Now let us use Mason's gain formula to determine the transfer function. So what is the transfer function? Transfer function is T. So T is equal to 1 by delta. Okay, 1 by delta into sigma k pk delta k. So you can expand it and you can write it as 1 by delta into p1 into delta 1 plus p2 into delta 2. Okay. So this is it. I will write T here. T is equal to what? 1 by delta into P1 into delta 1 plus P2 into delta 2. Okay. So 1 by delta into what is P1, G1, G2, G3, G4 into 1. Delta 1 value is 1. P2 is G1, G2, G6 into delta 2 value is 1 minus G5. So just substitute delta in the next equation, you will get this T. This is the transfer function for this given system. Okay. Next, I will solve one more numerical problem and just deleted it, but I did not copy it. Huh? Okay. So this is the last numerical problem that I am going to discuss in today's session. So here, find the overall gain C of S by R of S, that is transfer function. So we have to find the overall gain C of S by R of S for the signal flow graph shown in the figure. So this is it. So first of all, what we have to do, you have to determine the forward paths, number of forward paths. So let us see how many forward paths are there here. From node 1 to node 2, node 2 to 3, 3 to 4, 4 to 5, 6 and 7. Notations, node notations are already given, so we need not worry about the node notations. And okay, that is one forward path. Next, what else is there? From 1 to 2, 2 to 6, you can't go. 1 to 2 to 3, 3 to here, we can't go. From 4 to here, we can't go. So there is only one forward path. In this given signal flow graph, there is only one forward path. Okay, so there is only one forward path, so k is equal to 1. K is equal to 1. So gain value, forward path gain, let us assume notation P1. So what is P1? G1 into G2 into G3 into G4. P1 into G2 into G3 into G4. Okay, so I hope we have understood. Next, let us see the individual loop gains. So first of all, we must be able to identify the number of loops. I'll show you. I'll just make some modifications here. So let me check how many loops are there in this given circuit, or sorry, not circuit, signal flow graph. In this graph, I should say, this is the graph. So how many loops are there? So from 1 to 2, of course, it is understood there is no loop at all. And from 2 to, see, from 2 to 3, 3 to 4. From 4 to 5, you can't move from 4 to 5, 4 to 5, 5 to 6. Okay, 5 to 6. From 6, it is returning back. So this is one loop. Okay, we have got one loop. Next, from 3 to 4, 4 to 5. From 5, it is returning back. So this is another loop. So we have got two loops till now. Next, From 2 to 3, 3 to 4, 4 to this in this way, 4 to 6 you can't move, okay. And from 4 to 5, 5 to 6, 6 to 4, okay. So total we have got total 3 loops here, okay. Total 3 loops we have got. So let us go back. So total there are 3 loops. Of course I have written here, but simply whatever I have written, if I read that, it is of no use, isn't it? So if anyone is listening, then they can understand. So okay then. Individual loop gains. P11, P21, P31. So there are 3 individual loops. So you have got P1 notations here, individual loop gain notations, P11, P21, P31. So what were our loops? 4 to 5, 5 to 6, 6 to 4, one loop. 3 to 4, 4 to 5, 5 to 3, another loop. 2 to 3, 3 to 4, 4 to 5, 5 to 6, and 6 to 2, another loop. Total 3 loops were there. 3 loops are there. So what are their loop gain values? P11 is equal to minus G3, G4, H1, minus G2, G3, H2, and P31 is minus G1, G2, G3, G4. So this is it. These are the 3 loops and their gain values. So I hope you have written. Now let us determine the gain products of non-touching loops. Next step. So for that, let us see, is there any pair of loop which is not touching? For that, it's better to look at the loops. So there is node 4, node 5, and node 6 in this loop. So here node 4 is there, node 5 is also there. So loop 1, loop 2 are touching, and in loop 3, 4, 5 nodes are there, 4, 5, 6 nodes are there. So loop 3 is also touching loop 1. And if you compare loop 2 with loop 3, common nodes 4, 5, 4, 5 are there, 3, 4, 5, 3, 4, 5 are there. So loop 1 is touching loop 3, loop 2 is also touching loop 3. So there are no combinations of non-touching loops. So this is the first problem which we have got without combination of non-touching loops. So it's so simply gain product of 2 non-touching loops. So I'll just minimize this. This is it. So gain product of 2 non-touching loops. I had to do some modifications here. Actually, just before the class, I just changed the design, and I couldn't get time to do the modifications, because whenever we change the design of the slide, all the settings will change. And to be frank, I just forgot. I didn't see the time. 2 o'clock. I just announced the class at 2 p.m. I didn't see the time. I just suddenly I saw that it's 2:10, and I started. After that, I just turned on my system and I started giving the lecture. Okay, so that's it. So there are no possible combinations of two non-touching loops. Okay, so three non-touching loops, of course, we didn't check till now. Three non-touching, all these three are in combination, isn't it? 4, 4, and 4 common node is there. So even 3, when 2 is not possible, of course, we can check for 3. Okay, if two non-touching loops are not available, we can check for 3 non-touching loops or 4 non-touching loops, 5 non-touching loops and all we can check. Okay, so if those many loops should be there, of course. Okay, if many loops are there, we can go for 3, 4, 5 and all. Okay, so here there are no possible combinations of non-touching loops at all. So you just you can write a statement. You just write gain product of two non-touching loops and you can write this statement here. Okay, now let us calculate the delta and delta k value. So how many forward paths are there? Total only one forward path was there. So k is equal to 1. Okay, k is equal to 1. Now what about delta? Delta is equal to 1 minus what? Sum of the loop gain values plus sum of the combinations of non-touching loop gain values. So there is no combination at all. That's why I didn't write anything here. Okay, so there is no combination at all. So okay, 1 minus P11 is the loop gain of loop 1, loop and P21 is loop 2 and P31 was loop gain of loop 3. So we have got P11 value is minus G3 G4 H1 minus G2 G3 H2 minus G1 G2 G3 G4. Okay, so you will get, you just simplified, you will get 1 plus G3 G4 H1 plus G2 G3 H2 plus G1 G2 G3 G4. Okay, so what about delta 1? Delta 1 is equal to 1 minus 1 represents what? First forward path. So 1 minus, is there any part of the graph which is not touching forward path 1? There is only one forward path. So let us see, is there any part of the graph, okay, which is not touching forward path 1? There is no part. Okay, all are touching forward path 1. Okay, so 1 minus 0. So 1 minus 0, since there is no part which is not touching forward path 1. So delta 1 is equal to 1. Okay, so we have got the delta value and we have got the delta k value. Now we can go for, okay, we can go for this transfer function using Mason's gain formula. Now let us see the transfer function. So transfer function notation is T. Mason's gain formula is T is equal to 1 by delta. Sorry. I will take the laser because the slide changes unnecessarily. T is equal to 1 by delta sigma k pk delta k. So what is k1? So 1 by delta p1 delta 1. So here you should write T. Okay, T is equal to what now? P1 value is G1, G2, G3, G4. Delta 1 value is 1 by 1 plus G3, 1 divided by, of course, delta 1 value is 1 divided by 1 plus G3, G4, H1 plus G2, G3, H2. This is plus. Plus G1, G2, G3, G4. So this is the transfer function of this signal flow graph. So this was the smallest numerical problem, I think so, so far whatever we have discussed, because there were no non-touching loop gain values. I think I will conclude here.